Exercise 12.2, Problem 12, Discussion. A two-digit number is formed with digits 2, 5, 9. Right? Repetition is allowed. Find the probability that the number is divisible by 2 or 5. Again, the key point is or. Okay? Right. So, what are they saying? There is a two-digit number is formed. The digits are 2, 5, 9. And repetition is allowed. And we need to find the probability of the number divisible by 2 or 5. Okay, so key thing is repetition. So the tens digit the unit, okay, if they say not repetition, then let's say the number 2 is used for tens digit, the only 5 and 9 will be there for the unit digit. But in this case they say repetition is allowed, which means let's say 2 is getting into the tens digit. So unit digit can be filled with 2 or 5 or 9. So there will be 3 possible outcomes. Similarly, when the tens digit is taken by 5, the unit digit can be formed by 2 or 5 or 9. That is what they mean by saying repetition. If they say not repetition, let's say in the case of 5. So 5 comes in the tens digit. So unit digit can be filled only with 2 or 9 because already tens digit is having 5. So you cannot put 5 in the units digit. So you will have only 2 choices. That is what repetition means. But here repetition is allowed. So A will be the event of getting a number which is divisible by 2. And B will be the event of getting the number divisible by 5. Okay, so keep that in mind. Let's work it out. Two-digit number is formed with digits 2, 5, 9. Probably I should write the tens digit. Okay, can be filled with 2, 5, 9, and the unit digit can also be filled with 2, 5, 9. That's what they mean here, right? Next, probability that the number is divisible by 2 or 5. This is what we are asked to calculate. The same formula. Probability of A union B equal to probability of A plus probability of B. But if you are not sure that it is mutually exclusive, because a number cannot be divisible by 2 and 5. Am I right? If we say it's divisible by 2 and 4, they are not mutually exclusive. There are numbers which will get divisible by 2 and 4. But here 2 and 5, now no number will be there. Am I right? With these digits, I mean to say. Okay. So that is what is mutually exclusive. But for a safer reason, for safer playing it safe, let's keep that as add this also, minus A intersection of B. We'll show it that A intersection B is 0. Nothing to worry. Let's keep it. Let's avoid this actually. Okay, minus P of A intersection B. Please add that. Now let A be the event of forming a two-digit number divisible by 2, and B be the event of forming a two-digit number divisible by 5. Find n of s, which is the total count of numbers formed. So A is an event which is forming of two-digit number divisible by 2, and B is the event of forming two-digit number divisible by 5. And you have, for once, this is the event. Now first thing, we'll have to form all the numbers and find the total count of numbers. Then we'll have to select the numbers which form in this category, that is divisible by 2, and find the numbers which are falling under the category divisible by 3 and find n of b. Am I right? So first step is, with the 3 digits, form the all possible numbers. Then with those numbers, select the numbers which are divisible by 2, that is set A, and from which you can find n of A. Then select the numbers which are divisible by 3 and that are elements of set B, and from which you can find n of b. Right? Then using those numbers you can calculate probability of A. Probability of A is n of A, which we calculated here, and n of S, which is also calculated in step 2. Similarly, we can do for event B also, probability of B. Once we know this, substitute those values in this formula and calculate the value of probability of A union B, that is probability of A or B. What is probability of selecting a number which is divisible by 2 or 5. Okay, and as I said here, please add this minus P of A intersection B. We'll show it in the solution that there are no numbers which can be formed out of these 3 digits which are divisible by both 2 and 5. So add this minus P of A intersection B, but P of A intersection B will be 0. I'll show it later. Okay, so now let's get into the solution. So the digits are 2, 5, 9. So first list all the numbers which can be formed. How will you list? First put 2 in the units place, sorry, tens place. So 2 goes here, right? Now once 2 goes here, start putting the unit digit. So you can, because it is repetition, you can put the unit digit also 2 here. Then come over here. Tens digit is again 2 only. Okay, because you have not fully used all the numbers. So this 5 comes here, 25. Then 2 comes again here in the tens digit, and 9 comes over here. Now you have finished all the 3. So which means the tens digit from 2 needs to be changed into the next number, which is 5. Again, unit digit can be filled with 2. With 5 as a tens digit, unit digit can be filled with 5. Then with tens digit as 5, unit digit can be filled with 9. Next, come to this. So 5 is already exhausted, right? With 5, we have done all the 3 possible unit digit. Next, come for the tens digit. Fill it up with 9. Now, unit digit is filled with 2. Unit digit is filled with 5. Unit digit is filled with 9. So these are the repetitive numbers. So this is what means say this repetition of digits is allowed. Suppose they say repetition of digits is not allowed, means all these numbers will not be there. Okay, so the idea is fix the unit tens digit with one of these numbers and place the unit digit with all other digits one by one. Then move the tens digit to the next number. Again fill the unit digit with all the 3 numbers one by one. Keep doing it till all the numbers get exhausted. Sorry, all the digits get exhausted. Okay, so these are all the possible numbers which can be formed with 2, 5, 9. Am I right? Another way of doing it, that the tens digit can be filled with how many ways? It can be filled with 2 or 5 or 9. So 3 ways. The unit digit can be again filled with, because repetition is allowed, right? So it can be also filled with 2 or 5 or 9. So it can be also filled with 3 ways, filled in 3 ways. So it is 3 into 3, 9 ways you will get the number. So you see, count the number 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is how you need to verify it also. So n of s is 9. Now let a be the event of forming a 2-digit number divisible by 2. Okay, so pick the numbers which are divisible by 2. 22 will come here because a is divisible by 2. Will 25 go there? No. 29? No. Because it is not divisible by 2. 52? Yes, comes here because it's divisible by 2. 55? No. 59? No, it's not divisible by 2. 92? Yes, it will come here. 95, 99 will not come because they are all not divisible by 9. Right. So n of a is how many numbers are there divisible by 2? 1, 2, 3. N of a is 3. What is probability of a? N of a divided by n of s. What is n of a? 3. N of s is 9. So 3 by 9 is probability of a. Now let b be the event of forming a 2-digit number divisible by 5. Right? Because we want divisible by 2 or 5. So let b be the event. So b will be equal to, which is divisible by 5, that is 25. 22 is not divisible, so it will not go. 25 will go, right? 29, no. 52, no. 55 is divisible by 5, so it can be added, right? Then 59 will not go. 92 will not go. 95 will go. It's divisible by 5. 99 will not go. So the 2-digit number divisible by 5 is this list. How many are there? 1, 2, 3. So n of b is 3. And probability of b is, okay, we just need to add a comma here. Okay, probability of b is n of b divided by n of s. N of b is 3. Okay, and n of s is the same 9. So 3 by 9 again. Both are 3 by 9. Now we need to find a number which is divisible by 2 as well as by 5. So we select any of these things. So it has to be in A and B, right? So let's pick up the set A. Is this number divisible by 5? No. Is this number divisible by 5? Because this is divisible by 2, right? This list is divisible by 2. So all we need to check which number is divisible by 5 and pick it up and go for A intersection B. Is this number divisible by 5? No. Number 52? No. 92? No. So A intersection B. Okay, A intersection B. It's a null set. There is no element which will get in the digits, in the 9 numbers. None of them is divisible by both 2 and 5. Or n of A intersection B is 0 and P of A intersection B is n of A intersection B is 0 divided by n of S. So 0 by anything is 0. So probability of A intersection B is 0. Whenever probability of A intersection B is 0, events are mutually exclusive. That is, in this set of numbers, there is not a single number which is divisible by both 2 and 5. That's what it means. Okay. Next. Now we have the values of probability of A we have, probability of B we have. Substitute those values. So probability of A union B, which is nothing but probability of a 2-digit number divisible by 2 or 5 is 3 by 9. Right? I hope you remember. Probability of A is 3 by 9. Probability of B is 3 by 9. Correct? So probability of 9 is 3 by 9. Probability of B is 3 by 9. And probability of A intersection B is 0. So there is no point adding it here. So 3 by 9 plus 3 by 9, that is 6 by 9, or it is equal to 2 by 3. Therefore, probability of forming a number divisible by 2 or 5 is 2 by 3. Okay. So I hope I made it clear. If not, please go through this problem one more time. It will become clear. Thanks for watching this video.